So on lesson 4, this book starts off with a 2-page investigation on a fairly simple idea. So I'm going to give you the Coles Notes version of it, and then we'll just do the examples. They want you to use a ruler and all this and measure stuff. I'm not too interested in that, are you? So let's just take a look at the one example that they did. Let's take a look at 1A. All right, they have length of rectangle B, length of rectangle A. So let's say that this length is 6 and this length is 3. Rectangle A and rectangle B are similar, which means what? Their sides are in proportion. So, therefore, if angle A had a width of 2, rectangle A had a width of 2, what would the rectangle have a width of here? 4. Very straightforward. Do you agree? Okay. How this would be done, we would say we have this thing called scale factor. Scale factor would be some new thing divided by some old thing. So often they use the terminology model and original because, for example, say you had a model car and you had the actual car. Okay, and then you do a scaled down version of the actual thing. So you would put the model divided by the original. So for us, we used 6 and 3 to find out that the scale factor was 2. This was 6, this was 3. And notice that we line up dimension. Like we use 6, 6 goes with 3, obviously, and 4 goes with 2. We don't cross dimension. Like 4 doesn't go with 3 and 2 doesn't go with 6. So be consistent in that way. When you divide 6 and 3, obviously you get 2. Okay? So then, therefore, if I know that this is 2, all I have to do is multiply by 2, and I'll get 4. Okay? You can also do cross multiplication. 6 goes with 3, and 6 goes with 3, therefore 4 goes with 2, and you have equal proportions. 6 over 3 is equivalent to 4 over 2. They both divide to get 2 equals 2, which is the scale factor. 2 equals 2, that's the scale factor. Okay? So let's try to make some stuff up with C and D. Okay. Okay, let's say that C is 8 and D is 2. Let's say that this length is 6 and this length is question mark. Please, now, go ahead and find that question mark. Not so obvious this time, right? Not so obvious. Anybody got it? Yell it out. Beautiful, 1.5. Okay, how did I do that? 8 goes with 2. Do you agree? Therefore, 6 goes with question mark. When you have that structure, fraction equals fraction, you must, louder, cross multiply. Cross multiply. So 6 times 2 is 12, divided by 8 is question mark. 6 times 2 divided by 8. 12 over 8. What? Eight goes with 2. 6 goes with question mark. Yeah, 12 divided by 8. That's 1.5, right? Yeah, we're good. Guys okay with scale factor? Okay. Now, just a little heads up. Today is linear scale factor. It's very straightforward. On Monday, we'll do 2-dimensional scale factor for area, and on Tuesday, we'll do 3-dimensional scale factor for volume. Okay? And that's where we're headed. Let's take a look at linear scale factor. We're going to call that scale factor K. And it's just going to be a ratio, just like we've been talking about the past couple of days. K is going to be some ratio. And there's lots of different things that you could call it. You could call it the new thing over the old thing. You could call it model over the original. Heck, you could even call it A over B. It doesn't matter what you call it. It's just a ratio. Scale factor is a ratio. Now, we know that ratios can be bigger than 1, or they can be less than 1. If you have a scale factor, K, greater than 1, then you have an enlargement. This is like you have your face on your profile for Facebook, and then you grab the corner, and then you drag the corner, and you enlarge the face. That's an enlargement. You know when you grab the corner and you shrink it? That's a reduction. So if your K value is less than 1, but of course bigger than 0, because if it was 0, you would multiply by 0 and you'd get nothing. So between 0 and 1. That's between 0 and 1. So an example of that would be like K is 1/2. That's an example of a scale factor that would reduce. If you multiplied everything by 1/2, would it reduce? Yes, it would become half as large. If you multiplied everything by 2, everything would double. Would it enlarge? Yes. You can also express these ratios as percents. Okay? So that's a good little chunk of notes there. And again, we're going to skip this investigation because it takes rulers and measuring, and I don't got time for that. So we can flip this page, and we will just jump into these 2 examples. I'll even get you started into your homework, and then I'll give you the quiz, and you guys should be feeling okay. I'm not going to assign anything for this weekend if you're up to date. So you should have enough time in class to get everything done, so that going into this weekend, you can focus on your other classes, maybe your English and social or something like this. Okay? So let's take a look. Class example 1, determine the scale factor. Okay, we're going to call scale factor K. So determine K. That will transform P to Q. And give your answer as a ratio, a rational, and a percent. Olivia, Trinity, focus. Now you're famous on YouTube. Remember, we're going P to Q. And remember that it's linear scale factor. So you're only interested in one dimension. That means you're only interested in these lengths. So what is the length for the base for P? 4. What is the length for the base for Q? 3. So how could you determine K, the scale factor? How could you determine K, the scale factor? Put it away, please. The new thing divided by the old thing. Remember, we're going from P to Q. So we're going to go 3 over 4. Remember, that's the new one to the old one. New to old. Remember that. Or model to original. So I'll put those notation in there. This is new. This is old. The new one over the old one. Put 3 divided by 4 in your calculator. You could probably do that in your head. 3/4. How much money is that? 3/4. Yeah, 75 cents, 0.75. Now, you guys are smart people. I like dash 2s. You guys are typically pretty self-aware. You guys get it. You know the real world. Right? Did that shape get bigger or smaller? Smaller, obviously. And this number for the scale factor is smaller than, beautiful, who said that? Beautiful. It's smaller than 1, which is exactly what this last page, a couple pages ago, said. Oh, I'm glitching. We have some lag. Come on. All right, so this page here, a couple pages back, do you need to know scale factor greater than 1, scale factor between 0 and 1? You need to know that. All right, now, back to junior high. A ratio. You could write it like that, or you can write it as a fraction. Either of those is perfect. As a rational number, that's your decimal. And as a percent, remember, you can multiply by 100, and you'll get the 75%. Easy, right? Beautiful. Beautiful, beautiful, beautiful. Okay, Sarah increases the length and width of a rectangular 8 by 10 photograph by a factor of 5 to 2. Okay, 5 to 2. Will that be an enlargement or a reduction? Good. I'm hearing more and more of the proper answer. Remember, the first one is the new. The second one is the old. So if the old one was 2, the new one will be 5. You can also put 5 to 2 in your calculator. 5 divided by 2. Help me out. 2.5. What do you know about 2.5? Greater than 1. Greater than 1, therefore it is a enlargement. Calculate the new dimensions of the picture. Okay, So, the 8 by 10 photograph. This is 10, this is 8. Scale factor is very simple if you know the scale factor. So, all I have to do is take each dimension and times by the scale factor. So, the new picture, which is an enlargement, 10 times 2.5, that'll be 25. And 8 times 2.5 was that 20? Okay. You can also do it this way. 5 to 2 ratio. Whoa. What is happening? Wow. What is wrong with this? Okay, I'm just going to pause the video, do it on the whiteboard. All right, so for the last one, it says show that the ratio 5 to 2 also works for the perimeter. And look at their terminology as well. New versus old. Okay? So, let's take a look at the perimeter. Do you guys remember perimeter? You just add up the sides. 10 plus 10 plus 8 plus 8, 20 plus 16, 36. This would be the old. Now, let's call that perimeter 1. Perimeter 2, this is the new perimeter. We have to use 20 plus 20 and 25 plus 25. 20 plus 20 is 40, plus 50 is 90. This is the new. And we always do the ratio of new divided by old. Let's check that ratio. 90 divided by 36. Put that in your calculator, and you better get 2.5. Does it work? Yes, it does. 90 divided by 36 is 2.5. This is also 5 to 2. The reason it's the same is because perimeter, what dimension is perimeter? Perimeter is simply a length. So it's one-dimensional, and that's what we're doing. One-dimensional scale factor. That's what we're doing. Next week, I will show you two-dimensional scale factor. So let's go to the homework. Sure. Yeah. Let's go to the homework, and I'll do a couple for you. Good on this slide? Okay. Let's have you quickly do number 1. I'll give you 1 minute, then we'll go over the answers. And all you have to do is put reduction or enlargement. So you can put E or R. What's the first one? What's the decimal for 2/3? 0.6. That is less than 1. Therefore, this is a reduction. The next one, because 1.2 is greater than 1, therefore enlargement. And now the last one. Because it's 80% of the original, if you were 80% of something else, you wouldn't be completely the same, you'd be smaller. Not 100%, but 80%. Quickly to decimal, this would be 0.80, which is less than 1. Therefore, reduction. Not bad, hey? Okay, I'll let you try number 2, except what do I measure? For a circle, what's the defining feature? Diameter or radius. I would just use radius. I would just use radius, because that's how circles are made. You pick a radius, and then you just go around. And that's how you make a circle. So what's the original radius? 2. Oh dear. Now what? 2.5? All right. Let me pause this, and then I'll show you what I would do with the calculator. All right, so I'll just put this up for you. 2.5 to 2. They both multiply by 10. You get 25 to 20. They both divide by 5. 5 to 4. So that's the ratio you're looking for. As a decimal, that's 1.25. And as a percent, that's 125%. So you should be able to spot percentages if they're greater than 100, enlargement. But were you able to get this fraction with whole numbers with your calculator? Yeah, so some calculators will help you out there, right? The only thing I'm saying is if I gave you 2.5 and 2, and then the multiple choice was like find the right ratio, and 5 to 4 and other possibilities were there, like that's a free question if you can just pump into your calculator. Okay, let's go ahead and jump into 3. Determine as a ratio the scale factor that's used to transform A to B. So A to B, we're going this way. So if you're going A to B, this is new and this is old. Okay, and don't do crazy things like don't put this vertical with this horizontal. You have to be consistent. Okay? So if I'm going to do a horizontal, it has to go with this horizontal. Okay? So what's the new one over there? 3 to 4. And if you were to go backwards, it would be 4 to 3. So think about that. A to B is a reduction. B to A is the reverse enlargement. Okay? Go ahead and try B. All right, so let's keep going. I think most people are okay with question 3. Let's flip. Let's go to question 5. We'll do question 5 together. This will be the last one I do for you, or with you. You'll finish it off. I'll give you the quiz, and then you can finish any previous homework for the rest of the block. And then when you come back on Monday, we'll mark some of these quizzes and get caught up with quizzes. Okay, diagram 2 is a reduction of diagram 1. Do you agree? Okay, state the scale factor. So if I want the scale factor, that means I'm solving for k, and I have to do a new divided by a old, or a model divided by original. I just like new and old. It's so easy. So 6 would correspond to 8. Do you agree? Sometimes they can be really nasty, and they might rotate it. Okay, so just be mindful of that. This one looks like they're being kind. Okay, and do you notice that those are the only ones that match up? Because x goes with 12, 4.5 goes with y, 12 goes with w, and z goes with 10. Okay, so you can only find the scale factor from those two. 6 over 8 or 8 over 6? 6 over 8, which is the same as 3 over 4 because they both divide by 2. And that ratio would come to a decimal of 0.75, which is less than 1, which would imply reduction because it's less than 1. So when you go to multiply all the original things, like if I want z, what would I have to multiply by 10? 0.75. 10 multiplied by 0.75 obviously is 7.5. It's multiplying by 10. I can't believe I used a calculator for that. But I did. So I challenge you to find w, y, and x. X will be quite easy to get. It's exactly what I did to 10. But what about if you got to go backwards? Good. Whoever said that. Okay, so I'll let you finish this one off. I'll show you the cross multiplication way to do these. And when I say cross multiplication, the proper word here is proportional reasoning. So check this out. 8 goes with 6, right? Therefore, 12 goes with x. Okay? Let's try that again. 8 goes with 6. Therefore, w goes with 12. See how that works? Let me do that again. I'll use a highlighter this time. 8 goes with 6. Therefore, $12 goes with x. See how I'm consistent that way? Now let's try that again. 8 goes with 6. No, I'm going to do that again. 8 goes with 6. Therefore, w goes with 12. And then you just cross multiply. And cross multiply always times the two numbers, dividing the thing across x. So 12 multiplied by 6, dividing out 8. 12 times 6 divided by 8. This one is 9. Over here, you would go 12 multiplied by 8 divided by 6 is w. W is 16. So we got w, we got x, and we got z. The only one I don't have is y, so you go ahead and try and find y on your own.